Okay, so let's try something here. We finished up talking about all of our fuel injection stuff. So how about we review, but let's try this. You have to raise your hand on the little thing, and then I'll call on you, and then you answer the question. I should do something like first one to answer 5 gets to like log out and go home or something. Oh, you are home. Never mind. Okay. So question number 1. The Bendix fuel injection system, is it direct injection, continuous, or timed injection? Oh, Mark's first. Go ahead, Mark. This works just like a game show. Whoever's first goes right to the top.
Direct injection?
Wrong. Bendix fuel injection system is not direct injection. Jace, you're next.
It's continuous injection.
It is continuous injection. And where does it inject the fuel?
Right before the intake valve.
There you go. Let me see. All right. Oh, that worked. Okay. Question number 2. Describe the air metering force. Steven, go ahead. Steven, you took too long.
Yep. Oh, no, my thing wasn't on. So you have 2 forces of pressure on each side, a positive and a negative, that push the pressure to the meter closer together. So the further it is together, the less it lets through, but the further it is apart, the more it lets through.
All right, let's move on to Zach. Zach, can you be
Is that not a good description?
a little less confusing?
So you have your impact air and you have your Venturi suction air in the 2 chambers, and the suction air pulls it to the right, and the impact air also pulls it to the right, which is your air metering force. A plus B is your air metering force.
All right, I was looking for Venturi suction plus impact pressure, which was the first thing you said. So very good. Oh, by the way, all these questions apply to the Bendix RSA fuel injection system for now. All right, what is fuel metering force? Daniel.
Yeah. So fuel metering force is a unmetering pressure of fuel minus metering pressure of fuel.
That is it. Very good. All right. Next question. What if the diaphragm, should I pull up a picture? Maybe I'll pull up a picture. Be helpful.
That would be very helpful.
Let me see. We'll use this one. Okay. Question. If the diaphragm between the metered and unmetered fuel rupture, the engine will be what? Eric. Eric.
Rich.
Well, we have to be specific.
It'd be rich because that you would lose the fuel metering force.
Okay, so I have rich at all power settings?
Yeah, except for idle.
Oh, there we go. Rich at all power settings above idle is correct. All right. Number 5, if the diaphragm between the impact and Venturi ruptures, the engine will be, looking for rich or lean description. Mark.
It would be lean.
Lean. All settings.
Oh, that's the part that I'm hung up on. I got to run it through my mind. All settings except idle. Because you have the idles. Say the whole thing then. You would have a lean mixture at all settings except idle.
Why would that be true?
Because you have the idle spring that holds the poppet open.
Excellent. That is correct. Let's see. As the metering orifice is enlarged, this one's too hard to actually answer. I think verbally like this. You have to read all the answers. So I won't do it. I'll ask it this way. As the metering orifice is enlarged, Is the pressure differential between a metered and unmetered become greater or less? Christian. Nope, Christian bowed out. Hector.
It become less.
Let's see. As the metering orifice is enlarged, the pressure differential between meter and unmetered becomes?
Less.
That doesn't make sense. I think I got the wrong answer. Oh, it's because it is the wrong answer. Thank you. Yes, becomes less is correct. Nice one.
That was the question, or you change it? You say it was a difficult question.
It was too difficult to read.
Oh,
The whole
okay.
thing, and for you, because the question is, as the metering orifice is enlarged, and that's the question, and you have to pick A, B, C, or D.
Oh,
And
I
like
got
all
you.
the answers are really long. It's like, well, if I just said that, you wouldn't know. So I had to read it, and then to make things worse, I'd accidentally circled the wrong one, and then I crossed it, and I said, no, it's this one, but I didn't see that. So you answered correctly. All right. Number 7, fuel dripping out of the impact tube while the engine is off is an indication of? Richard.
Boost pumps left on.
That is not correct. If you leave the boost pump on, you should not get dripping out of the impact tubes ever. Scott.
You got a leaky seal in between the air metering force chambers and the fuel metering force chambers.
That is correct. The seal right there is a leaking. All right. You don't have to put your hands down. I have a little clear button and I don't mind doing it, but you guys are cool. All right. Let's see. The flow divider is designed to control fuel flow and pressure at lower engine speeds. True or false? Jace.
I'd say that's true.
That is correct. The Bendix system, it is designed to control fuel flows at lower engine speeds. All right. Number 9, fuel nozzles are designed to meter fuel when? Jace.
At the highest power setting, so full throttle.
That is correct. Only at maximum RPM. It's kind of fun. It's like a game show host here. I just need a long microphone and I don't know, some sort of flashy thing. Get my, good night and all. They do.
Yeah, you need the noise.
I need
Applause,
some
laugh.
PK said he was going to hook me up one time in class with a little thing that said, little bells and whistles. All right. The fuel nozzles are designed to meter. I just asked that one. All right. So I'm not going to ask that one again. So now we're, okay, this one's going to be a little bit difficult. So maybe I have to write something here for you. So, fuel nozzle. So the next one is assuming, well, you guys just remember it. The next 3 questions, if a fuel nozzle orifice is partially clogged, consider the symptoms. All right, we have a fuel nozzle orifice is partially clogged. The cylinder on the clogged one will run what? Mark.
Lean.
That is correct. It will run lean. All other cylinders will run MJ.
Rich, because the rest of the fuel will go there.
Yep. And the last part is, and the fuel flow, the pilot will report that the fuel flow gauge shows, Hector. Hector's out. Okay, I'll clear this. All right. You have a partially clogged nozzle. Richard, what is the answer?
Rich.
Nope. The question is, the pilot will report that the fuel flow gauge in the cockpit shows, Kevin.
High fuel flow.
High fuel flow is correct. Fuel flow has increased. Has it actually increased?
No.
It has not. All right, excellent. All right, for the next 3 questions, assume that a fuel nozzle air bleed, the air bleed has been partially blocked. Therefore, the clogged cylinder will run. Scott.
Rich.
Rich is correct. All other cylinders will run. Heath.
Lean.
Lean is correct. And last one, we'll go with Steven. The pilot will report that the gauge in the cockpit shows.
The manifold air pressure will be lower.
No, that is not correct.
Fuel pressure, what? That's from the notes.
Yeah, you have to show me those notes.
The fuel pressure will be lower and indicating a low fuel flow, indicating even the fuel flow is normal.
All right, well, that's different. You said manifold pressure.
Oh.
So it shows fuel flow has decreased. That is correct. All right. Next question. The automatic mixture control operates by doing what? Zach.
Lows that expands and contracts with altitude.
Okay, but
Pressure and temperature changes.
Okay, what does it do to actually lean out the fuel then?
It cuts off the airflow between let's see on this. Cuts off the airflow between A and B.
It doesn't really cut off the airflow.
Well, it meters it more with a needle, an inverse needle.
Okay. I was looking for that picture. I don't think I have it readily available. All right. Yeah, is correct. The simple answer is the automatic mixture control operates by decreasing the air metering force. All right, clear. With the two-piece nozzles, if you lose the insert, what do? Mark.
Get a new nozzle.
The whole thing?
Yeah, because they're a match set.
That is correct. All right, moving on to Continental. Yeah, we'll go with that drawing. Question, the Continental fuel injection system has no means for sensing airflow, true or false?
True.
Answer is true. Whoever said it. Yes, it is true.
Thank you, Daniel.
All right. Number 19, the fuel pump used in this system is what type of fuel pump?
Rotary vane gear.
You have to raise your hand. Steven.
Positive displacement rotary vane engine.
That is correct. A positive displacement rotary vane pump. All right. The purpose of the squirrel chamber in the pump is to do what? PK.
To remove the air, right?
That is correct. To supply bubble-free fuel to the metering unit.
Did you say a squirrel?
Yes, I did say squirrel.
Well, that's wrong then.
So PK, you were wrong. I said squirrel. There is no squirrel chamber. So mark yourself -5.
I was like, what the hell is that?
The squirrel chamber. Well, if I could draw it, I'd put a little squirrel right there. All right. Let's see. Where am I at here? The purpose of okay, next question. The flow divider is designed to help meter fuel at low RPM. True or false? The flow divider is designed to help meter fuel at low RPM. Hector.
I think it's true.
That is false. The Continental system goes out of its way to make sure that you do not meter any fuel with the flow divider. Remember we had the double poppet on this one?
Oh, yeah.
Yep. Okay. -5. Next question. Where is the vapor line routed to? Mark?
The tank.
That is correct. To the tank. If some of you guys haven't answered anything, you gotta be quicker on the little hands up raise. Let's go. Continental again, of course. As the engine RPM increases, what happens to the fuel pump outlet pressure? Robbie.
All right, fuel pump outlet pressure increases.
And what about volume?
The total volume should increase too.
Excellent job. Because the pressure went up and it's a relatively a fixed orifice, and when the pressure goes up, the volume goes up as well. Okay, next questions are applicable to any and all systems. Just got to get my mouse to work. There we go. Okay. A blocked fuel nozzle may be cleaned with what? MJ.
The hops 9.
That's correct. How about a soft wire?
No, never.
Okay. The purpose of the boost pump is to do what? Robbie.
To provide pressure to the engine-driven fuel pump.
That is correct. That is one of the answers. Let's go to Steven. What is another one?
The pump provides more fuel than necessary and needed, so a return line, so it can go back to the return line.
And that is not one of the purposes of the boost pump. No. Hector.
In case of the pump fails, it will continue to run the fuel to the nozzles.
That is correct. Number 2 was backup system. Last one. Anybody want to, let me see who's got their hand still up. I think Robbie, you got it? Nope. Yeah.
What was the question?
That's right. I was going the wrong way. So Heath, we'll go with Heath. What's the third?
To aid in starting.
That was the first one, I think. Provide fuel for initial startup was the first one. Second one on here was a backup pump, and the third is.
Well, someone else said. Oh no, you.
Because I have written. Maybe that's wrong then. Huh? Provide.
Reduced possibility of vapor lock was the answer we were looking for.
Prime the system too.
What's that?
Couldn't you also say to prime the system?
Yeah, but it's the actual answer on that one. Yes, that would be it. I wrote provide fuel for initial startup.
Oh, duh. That's what I thought. Okay, my bad.
Okay. Let's see. Hands down. Gravity fuel systems are never used on fuel injection or pressure carburetor systems. True or false? Steven.
True. What? Gravity? Oh, okay.
I'm just kidding.
Awesome.
It was right, but I wanted to try that.
Okay, I was like, what?
Well, now I can't make it stop. All right. So.
Where's the one for if you get it right?
I don't know.
Oh, yeah, I want to hear that sound because I got it right.
Well, I pulled it up on YouTube, so it's like I couldn't think of anything else. So we get. I guess I have to, and then it's, of course, it wants to keep. Wait, stop! No, go. Oh yeah, what is the correct answer?
Look up game show soundboard.
Game show. Game show soundboard. Oh, that looks awesome. Which one do I go to? Silence, nothing, game intro.
Oh, I don't know. I don't know about this one. All the ads are making me nervous.
Yeah.
It said Family Feud right there. It's like the third option. Well, never mind.
Now I'm just wasting your time. Sorry.
There you go.
Oops.
That's so.
Take bonuses. Nice.
And the FAA is going to be.
This is just going crazy.
What about for thinking?
Oh man. Okay. Let's see. Oh, Harry's already had his hand up. He didn't even know what the question is. Okay. So he was right. Gravity fuel systems are never used on fuel injection or pressure carb systems. All right. Vapor lock is most likely to occur when? Mark.
When it's hot.
Let's see. Yes.
That's kind of long.
All right, we'll be done with that. I've got a couple on here. What else we got? Anybody else? Hot. Zach?
When you have too much pressure in your fuel system.
The opposite of that.
Or yeah. When you have a vacuum in your fuel system, it causes
Okay,
it to
vacuum in your
boil.
fuel system. I got something else on here based upon the little video we watched yesterday. When did they get vapor lock? Had a hard time starting.
Air in the system.
Yeah, but that's really about what vapor lock is, air in the system. Steven, oops, wait, Harry's up. Harry went away.
I was thinking it was that one about the sharp bends in the fuel line.
Oh, there we go. Sharp bends. Okay, that one's good. I like that one. And Steven.
Yeah, Harry and Mark both took my answer, but they were saying about it being too close to the cylinder, where the cylinder would get it too hot.
Okay. Well, how about at high altitude? Let me see. High altitude and when the aircraft is hot. Those are the ones I have on here. So aircraft is hot. Remember that one. All right. If this tricky one, if the engine-driven fuel pump failed on takeoff, which system would you like to have installed on your engine? And which one would you not? Harry.
Definitely. Oh man, definitely have one that has a boost pump, like a fuel injection system, as opposed to a carbureted system.
Actually, this is all about the two systems. So between the Bendix and the RSA, which one would you rather have? Let's see, if the engine-driven pump failed on takeoff, which system would you rather have, the Bendix or the Continental? Or it doesn't matter because they both.
Oh yeah, the Bendix has the bypass, so that would probably be the way to go.
Which one?
The Bendix with the bypass.
Well, they both have bypasses.
All right, I had my 3 strikes. Somebody.
Yep. Moving on, Robbie.
As long as it has a bypass and a boost pump.
No. They both have bypasses and boost pumps. Who's next? Let me see. Got Harry,
Jace.
Robbie. Robbie's next.
I'll pass it on.
Okay. Jace.
I'd rather have the Lycoming system because it runs off of the air pressure and the Venturi rather than the engine-driven pump.
All right. So far, that'd be the correct answer. What happens to the Continental system when the engine pump fails and you run off the boost pump?
Is that for me?
Anybody can chime in.
It goes into bypass.
All right, hang on.
You lose control of like the throttle. It's either like, well, you max out at 75 or that's it, right?
There you go. Remember that the entire Continental fuel injection system is based upon the constant and predictable output of the engine-driven pump. If you lose the engine-driven fuel pump, you're going to only get about a max of 75% power. So would you rather have the Lycoming system with 100% power or the Continental system with 75% power?
Bendix, Lycom.
Bendix. So the answer is Bendix. All right. If the fuel tank vent is, let me erase this. If the fuel tank vent is plugged, what could happen? Mark.
You could collapse your tank because of the suction.
That is correct. Collapse the tank because of suction. And let's see here. When adjusting the fuel injection systems, the aircraft's installed gauges, ooh, I don't think I touched on this one, must be what? Robbie.
I actually didn't mean to raise my hand. I don't know why it was still raised.
No, you need to answer.
Harry's got it.
I'm just going to calibrated.
That is correct. I didn't. Oh, I know why. Wait. That was not good. There we go. Did you get the bell? Okay.
Service.
There we are. All right. Let me move on to some other stuff. I'm going to move you guys over here and stop sharing. Oops, that means that so you don't have to look at each other. And then this, and then just get it. Well, my bad. All right, where my thing here? There it is. Okay, we're going to talk about our lightning round here. This would apply to pretty much anything we've talked about since the beginning of class started. So the question is, describe the purpose and operation of a Venturi. Mark.
The purpose of a Venturi is to create a low pressure, high velocity area.
To do what?
Create a low pressure, high velocity area for air.
Yeah, you said that, but for what reason? Why do we want to do that?
So you draw air into the fuel system?
No.
I don't know if I understand the question 100%.
Well, it's a Q&A question, or not, it's an oral practical question, and that's the actual question that we asked. Describe the purpose and operation of Venturi. You did the operation quite well. What is the purpose?
Kevin, this just for carburetors, right?
Could be anything we've talked about
Anything.
Last several weeks. Yep.
So to get the right amount of air and fuel mixture?
Nope.
For air metering force?
Let me pull it back down. Re-ask. Okay, so anybody has this one, raise your hand again. All right, Jace thinks he has it.
To measure air.
Yeah, okay. So we've got the purpose and operation. I would be looking for something like, Mark did a good job with the operation, that it provides high velocity, low pressure air. And then the purpose of that would be to place it inside of the throttle body to, as Jay said, use it to measure airflow, or to use it to draw fuel out of a discharge nozzle would be a good one, or to use it to create air metering force. So I would say something like that. All right. What is the fuel metering force in a float type carburetor? Steven. Oh, you were just making noise. That's all. Zach.
Unmetered fuel, or it's the fuel metering force is A plus B plus C equals D.
Float type carburetor.
In a float type carburetor, the fuel metering force is the difference of the air in the Venturi to the air in the float chamber.
Very nice. I hate that. Fuel metering force is the difference in air pressure. Wow, who thought of that one? Good job.
Thank you.
What is the function of a metering jet? Scott.
Serve as a restriction, so you can have a difference of pressure in two areas or something like that.
Okay, I can buy into that. I would also accept something like it limits the flow of fuel. Let me see.
I don't know. He doesn't tell you that.
What is the purpose of a mixture control in a float type carburetor? Robbie.
To maintain the proper air fuel ratio.
Sounds like a good answer to me. Remember, this is exactly how it goes for your oral and practical. As an examiner, that's just how I ask it. What's the purpose of a mixture control and float type carburetor? And then you're going to say something like what Robbie just said. And then I, as an examiner, will decide, did what he say lead me to believe that he understands what it is? And if the answer is reasonably good, like that was a great short answer, then I just move on because you have to ask a lot of questions. I don't like to drag it out. So you always want to be careful to give a short, succinct answer. You don't want to do something really weird and stuff because then it's like, oh boy, you just went off the rails on that. All right, what is the purpose of an accelerating system on a float type carburetor? Mark.
To increase the fuel to the engine when you accelerate with a throttle.
Works for me. I guess I don't have to ask just the asterisk ones. Well, let's see. What type of accelerating system do carburetors have? MJ.
Well, there's two types, the well and the accelerating well and accelerating pump.
Very good. How is an engine shut down with a well type accelerator how is the engine shut down with a let's see. What do I want to ask? I'll change it. What RPM indications should result when the mixture control is placed into idle cutoff position when the idle mixture is set correctly? Eric.
A rise to 25 to 50 RPM.
That's
and
not
then,
it.
And then.
You got to get the rest of it.
And then it will die.
Yes, if you don't say the die, then I think you just thinking it just goes up and stays up, and that wouldn't work.
Makes sense.
Okay. There are two types of mixture systems. What are they? PK. Nope, you went away. Steven.
Accelerating and economizer.
Negative. Robbie.
The manual mixture control and automatic mixture control.
Not really what I'm looking for. Everything should have a manual mixture control. So there's two types of manual mixture controls. Let's maybe put it that way. What were the two types? Zach.
One would be like your idle mix, and the other would be your manual mixture control, like your actual hand mix.
Nope, I'm talking two different types of manual mixture controls. Harry.
One of them's back suction type, and I can't remember the name of the other one where it's just the direct impact on the flow of the fuel. But back suction, is that the one?
That is correct. You've got them both. So and don't forget, you don't always have to have the name. You're okay. You can always describe it. And it's, especially if I was an oral practical examiner, maybe as an instructor, I might be a little more critical, but as an oral practical examiner, I would absolutely accept descriptions and not names. Like, oh man, I can't remember what you called, but it's got that little needle that goes in there and it goes back and forth and it controls the fuel. And I'll be like, yeah, it's called the needle type. So, all right. So yes, we have the back suction and I'll say that the needle type. Next question. How is the back suction mixture control type carburetor shut down? Ooh, I stumped you. Hector.
Isn't it the same as with the idle control, idle cutoff?
No, it is not. Zach.
Because you can't put it in the idle cutoff because of the back suction. So you'd have to shut it off with the key.
That is correct. All right, that is 4:20. So you guys get a break.
goldfish today, and I've been watching them swim around in the